Okay, this is beginning of part 2. All right, now we're going to get into a little bit of the math behind projectile motion. Okay, we're going to leave this up for now. The kinematic equations that we used before were Vf equals Vi plus At. We also had Vf squared equals Vi squared plus 2Ax. And lastly, we had x equals Vit plus 1/2 At squared. Now you notice I'm not talking about the y direction. I'm just going to talk about the x direction in this for these kinematic equations. Okay, so let's talk real quick about the y direction. The y still has gravity. Okay, for the acceleration, we are going to substitute in g for everywhere where it says a, and we're going to substitute y in wherever it says x. Okay. So I'm going to write these down first. This is my y direction. I'm going to add a couple little subscripts too that I like, that I think help students a little bit, just to remember that this is the y. So I write Vfy equals Viy plus g, there's my substitution for a, gt. Next, it is Vfy squared equals Viy squared plus 2gy. And lastly, I might run into this a little bit, y equals Viyt plus 1/2 gt squared. So those are my equations for the y direction. If you look at some other people's, the way they write it might be a little bit different. They might not even put the y's in there. They might just say Vf, or it might say Vyi, or if you look at the textbook. But this is how I like to do it. So I like to say the velocity, the final velocity in the y direction. Okay, that'd be an example of Vfy. The initial velocity in the y direction. So that'd be Viy. Okay? So there is gravity still in the y direction. Now let's take a look at the x direction. I know it seems like a lot of equations so far, but this is actually not too bad. It's everything that we've already done. Now if you remember, in part 1 I said that the acceleration is actually 0. There's no error actually slowing down the projectile. Okay? That means everything with an a would actually go to 0. So you can see here, Vf equals Vi. That's true. So that equation goes away. Again, on this one, Vf squared would equal Vi squared? Absolutely. That makes sense. So that one actually goes away because there's nothing left. And then this one, all you're left with is x equals Vit. I like to write that a little bit differently, and I put the I and the x in there. For example, Ixt. So x is equal to Vix times the time. Okay? So there's only one equation for the x direction. So that's pretty nice. Okay? You notice I erased everything else, but I left this. Okay? The initial velocity. I'm going to change my color to red. The initial velocity is launched at an angle. We will call that theta. If you take a look at this, we have to solve for the initial velocity of the y and the x directions. Okay? This is a right triangle. We are going to use trig functions to do that. So if I go cosine of theta, that would be equal to Vix over VI. Okay. If I were to solve for VIX, I get VIX is equal to VI cosine of theta. And if you look at the example problems, we'll actually solve for VIX and VIY all the time, every single one we do. Let's look at VIY. VIY is actually opposite the angle, so we're going to use sine. So it's equal to VIY divided by VI. And if I solve for that, VIY is equal to VI sine of theta. So you should know the process behind solving for these. Okay? Too often students get wrapped up that cosine always goes with the x and sine always goes with the y. But truth is, depending on the angle you're given, you have to be careful. Now in these problems, it happens to be nice where most of the time, let me say it again, most of the time, there's usually cosine associated with the VIX and sine with the y. Okay? So this is the basics, the absolute basics behind projectile motion. Let's recap real fast, okay? I'm going to erase these equations. Okay, quick recap. 4 assumptions, okay? There's no air, gravity always remains constant, our gravity is always negative 9.80 meters per second squared because we are above sea level. Okay, so that's one of the big assumptions that we need to remember. All right, we have 4 different equations that we're going to use. Some for the y, some for the x. One thing I forgot to note, all right, when you have a projectile, okay, this is also reviewing, I like to act like a ball's being thrown up and it comes back down. That's the y direction. I also like to act like a ball rolls and it doesn't slow down, it doesn't speed up. That's the x direction. The only thing that links the x and y direction is the time. Okay? So here is my initial velocity. I act like I throw a ball up and it comes back down. And I also act like I have a ball here and I roll it along the x-axis. It takes the same amount of time for that ball to go up and come back down as it does for the ball rolling here to reach the final point in the path. Okay? Time is the only link. Right. We also said that you have to solve for the initial components, which we like to call VIX and VIY. After you solve for those, is there any use for this VI? No, there's not. Okay, you will never use it again. Okay. And I guess we should note up there, if gravity is 9.8, the acceleration in the x direction, I'm going to put a little x there just to help you out, is actually 0. Okay? So that's a recap of projectile motion. Remember, keep the x and y axes separate. Don't use the initial velocity, only use the initial velocity in each direction. I'm going to do a couple, 2, 3, 4 example problems, okay? So take a look at those. Those are ones that we've mostly have done in class. Okay, and it should give you a good review.